Hi, everybody. Can you just confirm again if you can hear me all right? Yes? Okay, perfect. All right, everybody. Thanks for joining and good evening. Let me start by sharing my screen and then I'll just brief you on what we're going to do today. Okay. Uh, okay. Can you confirm if you can see the screen? Okay, great. Mm. All right. So, hi, everybody. So you've all signed up for this NPTEL session, Essentials of Data Science with R Software 1, right? So this is a 12-week course, and every week you would have some lectures released for you, so which would tell you about the course that you've signed up for. There would be some questions, some assignments given to you at the end of each week to discuss, to basically see if you've understood the course content well. Okay, so give me 1 second. Just give me, sorry for the interruption. Just give me 1 second. Um, fine, I'm sharing my screen again. Okay, yes. There we go. All right, so yes, so welcome to this first live session. So the idea is that for each week, we would have one of these live sessions where we are going to give a quick recap of what was discussed in that week. We can practice some questions that would help you answer the actual questions in your assignment. And starting from the next week, we can also discuss previous week assignments so that if you've had any trouble understanding any questions, we can sort that out too. Okay. Does that sound good? This is, so mostly you can see that's not going to be a lot of people joining, so it can be as interactive as you want, or I can keep explaining and you can keep listening, but it'll be really better if you can directly unmute yourself to ask questions, or you can put it in the chat box. Okay, these sessions would be somewhere between 1 to 1.5 to maybe up to 2 hours long, but not more than that. And these, as you can see, these sessions are being recorded. So let me just show you something here. Yeah. So for this course, it's going to be on Mondays, 6 to 8 p.m. like you've joined today. The Zoom link that you've joined with today stays the same for the entire duration of this course. So it is supposed to be on all Mondays, but a few weeks here and there, I have a couple of other commitments, so I might not be able to join on Mondays. You would get emails in advance about any rescheduling. So for example, the next week's Monday, I have some other work, so it would be preponed and it would be conducted in like the next 4 days, so on 31st of Jan. That will be for week 2. Anyway, you would keep getting these emails. Also, these sessions are recorded, so they would all be uploaded right after the session on my YouTube channel. You would have the link to this sent to you again via emails. So please check the emails that you've used to sign up for this course. Also, anything that we discuss in these sessions, which is going to be this PPT that you're looking at, we would also have an R script that we would walk through during the entire session. So that would also be available to you right after the session. So I'll upload that to this Google Drive folder. Again, you would have the link to this also. In case, apart from these sessions, if you face any questions, there is a discussion forum under this Ask a Question tab on the NPTEL page. So it looks like this. So if you open Chrome, you can see the Q&A option. So if you go there, you will be able to see this discussion forum. You can have a new conversation. And again, oops, sorry. So yeah, again, so for each of your weeks, so this is how the tab for your session would the course look like. Every Friday, you would have some week's lectures being released, and sort of 2 weeks after that. So it's released on a Friday, and let's say 12 days later on that Wednesday, you would generally have the deadline to submit assignments for this course for that week. So don't miss out on the assignments, because if you are interested in getting a certificate at the end, these assignments have a certain percentage weightage associated with them. Okay. Alrighty. So we've got a lot of people joining in. So that's great. So I am a PhD student at IIT Delhi, and I'm doing my PhD work revolves around using R software quite a lot. So I hope I would be able to explain you some parts of this course well and answer any questions that you have. However, if we still get stuck somewhere, again, I would use that discussion forum to update you on the answers for things that we would not be able to discuss in these sessions. Okay, do you have any questions so far? Again, please feel free to unmute yourselves to ask questions, or you can directly write it in the chat box, up to you. And just to
Hello,
reiterate,
hello, ma'am. Hello,
yes,
ma'am.
hi.
Sorry, ma'am. Actually, I want to ask you about the exam. Can I ask you about the certification?
Sure, I can try. Sure, yes.
Okay. Thank you, ma'am. Actually, I recently filled the form of NPTEL exam, so
Mm-hmm.
I just want to that I would just want to confirm that if my form is submitted or not. Can you tell me? Means
Oh, okay. I think the NPTEL team directly will be able to guide you on that. You would you can check the website. There should be an email that you can ask your queries at.
एक्चुअली मैंने आज सुबह ही मेल किया था उनको कि मेरा
Mm-hmm.
फॉर्म सबमिट हुआ है कि नहीं।
Mm-hmm.
तो
Mm-hmm.
उन्होंने मतलब कहा था कि हम लोग को इस मेल से मतलब कोई भी अपना इंफॉर्मेशन नहीं मिला। मतलब मैंने पूछा था कि फॉर्म सबमिट हुआ है कि नहीं, बट वो
Mm-hmm.
क्लैरिफाई एक्चुअली नहीं हो पा रहा है। वो बोले कि इंफॉर्मेशन शायद से नहीं मिल पाया है। सो मैं थोड़ा
Uh,
कंफ्यूज हूँ कि फॉर्म सबमिट हुआ है कि नहीं।
okay. उसकी डेडलाइन कब तक है?
फेब्रुआरी 10 फरवरी तक।
ठीक है, तो आप फिर एक बार वेट फॉर दिस वीक, है ना? हो सकता है इस वीक में आपको कोई कंफर्मेटरी ईमेल आ जाए।
ओके।
अगर नहीं आता है तो आप
एक्चुअली
नेक्स्ट वीक
मैंने
एक बार।
ओके, एक्चुअली
हाँ,
मैंने फी वगैरह सब सबमिट भी किया है। मैंने फी वगैरह पूरा सबमिट किया
ठीक
है।
है। सो आई थिंक एक जस्ट वेट फॉर दिस वीक. You should get a confirmatory email. In case you don't get it by the end of this week, then you can send an email to them. Okay.
थैंक यू मैम, थैंक यू सो मच।
Okay. All right. Yes. Pushkal, if so the assignment deadline is like a particular Wednesday. If you don't submit, then the only thing is your points, if like even if you've given correct answers, those points will not be added to your final grade. So these assignments have some percentage associated in the final exam for your certificate. That detail is available on the NPTEL page. Just confirm that. So again, so starting next week onwards, so if we're taking session one, like these live sessions on Mondays, 2 days after that, that Wednesday would be the deadline. It's for the first week that the deadline is for the Wednesday after. So I think it's on the 5th of February. But next week onwards is going to be every Wednesday. So if you can just have a reminder, maybe set in your calendar, or like an alarm if you can set, it'll be nice. Okay. All right. Okay, cool. Great. Again, if you have any questions pertaining to, so if it's pertaining to the exam, which you think the NPTEL team might be able to better answer, then I think emailing them is the best option. I would mostly be dealing with the course content in itself. Okay. All right. So let's begin. So like I said, what we would be doing in these live sessions is basically a set of three things. One, we would have a quick recap of whatever was covered in that week. We would be using an R script for that. Again, we'll walk slowly towards making an R script, saving it, all of that. And then we will do some question solving. Now, base here, since it's primarily an R-based course, so these questions may not be completely mathematical. So you don't exactly need a calculator for that. But we'll see how to go about it. And then finally, we'll start after a week or two, where we will take a look at some of the previous week questions. And if you have any specific questions regarding those assignments, then we can solve those. Okay. Okay. So I will just actually stop sharing my video because my internet connection is not great at the moment. Okay. All right. I hope you can still see the screen and hear me all right. Okay. So this is something that you should definitely do before progressing, like before we go into week 2 and 3. Definitely install R on your systems. So if you go to this website, you will see that you can install, you can download R here. So what happens is when you click on download R, you would be redirected to something called mirrors. Now you can think of these as multiple pages which do the same thing. You can install R from any of these. The only reason why it's saved at so many places is to avoid any sort of traffic. You don't necessarily need to install it from your closest location, but it's nice if you do that. But again, you can do it from any of these links. So if I'm not sure if I can show that here, but the one for India, it's hosted by NICER, which is in Bhubaneswar. But again, any of these will work exactly the same. Once you click on the whichever mirror you want to install R from, you will see this option that whether you want to download it for Linux, for Mac, or for Windows. So select whichever is the appropriate one for your computer, for your laptop. And once you've done that, then the next step is, so this was not, so R is the language, okay? This is where you are going to type in, like this is the language in which you type your commands. Now, R by itself comes with something known as a console, which is what was used in this course in the first week's lectures. Oh, and by the way, before I go any further, definitely watch the week's lectures before we conduct these live sessions, because I will not be explaining everything. So if you have not already watched the lectures, you may have a hard time following up. So these sessions are more for doubt clearing. So you have to have, it's better to have watched the videos before we clear any doubts, right? Okay. So yeah, so what was done in week 1 lecture was that you can install R, and there's also something additional which is called R Studio. Again, you don't necessarily need to install R Studio, but it is like sometimes when you're like, if you're working a lot in R Studio offers some benefits. Okay. So you can, when you go onto this page, it will automatically detect what your operating system is. So I am here working with a Mac operating system. So it already shows me that, okay, it's a Mac operating system. So you can download it for that. And then you can follow, it'll have clear instructions to install it on your system. Okay. Again, if you get stuck somewhere, it's not very difficult to troubleshoot, but if you do, you can let me know and we can troubleshoot that. So the thing is, so if you would have seen the week's lectures, you'll see that the console is basically one page, which offers you something like a screen that you can type your commands into. RStudio does a few additional things. So basically, there are these 4 windows or 4 panes that you can see in RStudio. The bottom left one here, if you can see here, it's called a console. This does exactly what the R console does. The source pane here, as we will see, is where you can type in your scripts. Okay, so you can type in, but you don't need to execute those commands. So, for example, today in this class, I want to discuss some, let's say 50 commands with you. Okay, very basic ones, but let's say there are 50 of them. Now, I will not remember what each of those 50 are, right? So I've already written them, and I will directly open those 50 in the source pane and then one by one execute them with you in the console. And then the output of those things, some of the outputs we might see in the right 2 panes, some of the outputs we'll see in the console itself. Okay. So I've taken this course, like I was also a TA for this course 2 semesters back. So in last January to April. And the way we did it that time was, so in the lectures, you are being explained how to work on R console directly. And here in the live sessions, I'll show you how to do pretty much the same thing in RStudio. And then, so it gives you a flavor of both the things. So you can then decide which one you feel better, although there's not much difference in how you type into them. It's just the output looks slightly different. Like the way it's presented is different. The output itself is still the same. Okay. Alrighty. Oopsies. Okay. I need to switch off this annotate thing. I'm not sure how to do that. How do I do this? Okay, maybe this is going to work. Give me one more second. Oh, a lot of people have joined. Great. Welcome everybody. So again, just a quick recap of what we'll be doing in these sessions. These live sessions are for doubt clearing. So once you've watched the week's lectures of this course, every week we will have these live sessions where we can quickly discuss what was taught in that week. And then we can solve a few practice questions. And then starting after a couple of weeks, we can also discuss any of the previous week's assignments. And then we can obviously, along the way, we'll keep discussing any doubts, any questions that you've had. Okay. All right. Again, please interrupt me if you have any questions at any point of time. If there are no questions, I'll assume everything is going smoothly. Okay. So this is what an empty RStudio console or everything, the window looks like. And once we've filled a lot of things, it gets all colorful and nice. So this is what we'll be doing throughout this course. This is just an example. So again, like I said, in these live sessions, all the demos that I'll give you are going to be in RStudio, and the videos are in R. So they'll just complement each other. Nothing very different. This plot is not. I forgot to delete this screenshot. It's for later. Okay. Anyway, so what we'll do is, so I have this RStudio open with me. Okay, so let me actually close this and let me open it from the beginning. Okay, so I'm shutting this down. And now here I have this folder. I have made something called an R script here. Okay, so you can see it has the extension .r, and you know the computer identifies this as an R source file. Okay, it's nice. I don't know what it looks like, but let me do a right click and sorry. So while of course I can open it with RStudio, that's the default thing. I can also open it with R. I can also open it with any text editing tool. So if you have Notepad or TextEdit or whatever it is in your computer, you can open it through that also because it's a basic text file. Okay, so it looks like this. So you see here, right? So I have something written here already. Okay, so there's something written. Some lines here you can see they begin with a hash symbol, some lines don't. There's some mathematical operations, something written, lots of brackets, lots of operators here and there. Okay, fine, looks good. Now, again, I can also open it with R directly. Okay, so this would look more familiar to you to what was discussed in the session, right? So you have this, there are two things. One is that script directly. Again, it's the same thing that we just saw in Notepad right now. And on the left side here, you can see that there is something called the R console. And the important bit about this is the last line here, that has a greater than symbol and a cursor that's blinking. So this symbol is what tells you that the computer, that the software is now ready to accept some commands from the user, user being you. Okay, you can type things now directly here. So again, whatever I'm showing here can also be done in RStudio and vice versa. So I'll just close this for now. It says, do you want to save the workspace image? We can hit don't save. We don't need to save the history, so as to say. And now I can open this with RStudio. Okay. So when I do that, now this script, this exact R script that you see right now, this is what I'll share with you at the end of today's class. I'll upload it on that Google Drive, and you'll have the link to that Google Drive as well. So you can also do the exact same thing that we are doing right now in this course, okay? In this class. Okay, now here you can see, okay, just ignore this error for now. I tried something and it did not work. So it's giving like a default error, but this error won't show up in your computers. So what you can see now is, when I had opened it in the notepad, there were no colors for any of these lines. But here you can see that each of the lines, there's some color, some of the things are green, some is blue, red, etc. It might not be the same colors in your computer, but doesn't matter. The thing is that RStudio is able to identify some lines, some words, some entries as something special. Okay. So now we'll walk through what each of these lines are indicating. So if any of you have done any sort of coding before, any language, the hash symbol stays consistent across all of them, more or less. This means these are comments. These are things that we humans have written for us to understand. This is not for the computer to understand. Okay, these are called comments. So here, for example, this is the title for, let's say, the script. You don't need it, but it's better to have it. Okay. Now, what I can do is, so again, there are lots of things that you can, so these four things as such right now, the two things on the right, they are absolutely empty. The one on the top left, that's your script. And the one on the bottom left, that's your console. And the last line in the console, as we discussed, that is a greater than symbol and a blinking cursor. So this console is actually where I've just increased the font size. So this console is where you can type your commands. We can directly type commands. Okay. So have your eyes here. Let's say I'm writing 8 plus 9. And when I press enter, it gives me 17. Okay, correct. I can write 3 into 7 and then gives me 21. So again, great. All right. So what I'm doing right now is I am using R as a calculator. Okay. So again, when you want to do calculations, you have the basic four mathematical operators: plus, minus, multiply, divide. And there's also this fifth one called the power. Okay. So for example, if you want to find out 3 to the power 4, okay. Again, this is called the caret symbol. On the keyboard, you will have it when you press shift and 6. So 3 to the power 4 means 3 into 3 into 3 into 3. So that's going to be 81, right? And that's what you get. Another way to write the same thing is 3. And when you can put 2 asterisks here, 2 of these stars, and then do like 3. So this also means 3 to the power 4. So this also gives you the same thing. Okay. So now here I have, so now for example, just forget that there is no script here at the top. For example, this is all the commands we've discussed today. Okay, so I can share these with you, right? I can copy this. I can say, okay, copy, and I can paste them in a new empty document, and I can share that with you. but then it's not the best way to share because then you have all these extra symbols here and there. Again, we'll discuss what these symbols or these numbers tell you. But this is not, so I just typed 8 plus 9. So what I want to share with you is just 8 plus 9 rather than this greater than symbol and this 1 in square brackets and then also the output. You don't need the output because whether you execute 8 plus 9 or whether I write 8 plus 9, it should be the same thing. So you don't need outputs. You just need the input script. Okay. So which is where this script comes handy. So here on the top, here it's just the inputs. So what we'll do is, there are 3 ways to run this. So again, executing commands, running commands, writing commands, they all mean roughly the same thing. Okay. So what you can do is, once you've written something in a script, in this file, in this .r file, you can highlight the entire thing and then you can press Command Enter or Control Enter. Either of them work. So yes, Control Enter. So again, so I've highlighted this and then now on the keyboard, I'm pressing Control Enter. So now you see what happened is this highlighted thing got copied and pasted here and also executed. So it's almost as if I copy and paste and I press Enter. So that's what's happening when I'm doing Control Enter or Command Enter. Okay. Does this make sense? You can just give me thumbs up or yes, no. Okay. You can say or put it in the chat just so I know that you're following.
Yes, ma'am, we are getting it.
Okay, perfect. Great. Okay. So fine. So this is how we do. If you want to execute the entire line, you don't need to select the whole thing. Even putting your cursor somewhere on the line does the same thing. So here I've not highlighted it, but my cursor is just somewhere. And now if I press Control Enter, again, the same thing happens. Okay. Fine. So now again, so whatever we just talked about today, I have also written it already as commands. Sorry,
Hello.
comments. Yes. Hi.
Hello. Hi, what's the purpose of doing this?
Purpose of the
Using when I have the console, when I can do it, why should I do that with
yes.
the,
Yes.
what is the
Okay.
purpose of doing it?
Okay. Yes. So now, for example, on the top left, you can see there's lots of things that we want to walk through today, right?
Okay.
Now,
Okay.
I can have this written with me somewhere on a paper and then I can write it directly on the console. But then
Okay.
if I want to run the exact same thing, maybe a year later, if I want to run it or if I want to share it with somebody, this console, this script helps. I can just share the script with you directly and then you can do the exact same thing.
How do I share it?
Oh, this is just, so you can see here, this script, right? This R thing. I'll just share it with you via Google Drive. I'll just upload it on the drive. You can download it and open this again. Yeah.
Okay. So that means I can put my data into this and I can share it with someone and they can also work out on the same art. Is it
Exactly.
what you're trying?
Exactly. Yes.
Okay. Okay. Done. Thank you. Thank you. Yeah.
Yeah. All right. Okay, cool. So yes, so again, this is just another example. Like here we saw 3 to the power 4, this is like 2 to the power 3. Again, this is the same thing. So of course, when you're doing multiple mathematical operators, you have to focus, like the order is important. So again, BODMAS is going to be followed. Brackets and then division, multiplication, addition, subtraction, and so on. Right? So if you execute, suppose this line, 4 minus 6 into 5. So, 6 into 5 is being calculated first. That gives you 30. And then 4 minus 30, that gives you 26. Okay. Now, so the way it was taught in school is you have these 3 types of brackets, right? So you have this bracket, the curved bracket that you see on your keyboard above numbers 9 and 0. Then you have these curly brackets, which you see next to the letter P on the keyboard. And then you have these square brackets also next to the letter P on the keyboard, right? So maths, when you're writing it on paper, you use these different brackets. right? The outer bracket, middle bracket, inner bracket, and so on. But when you're using brackets in R for mathematical operations, you only stick with the first one, the curved bracket only. And what you might have observed is when you're typing the opening bracket, so I'm only typing the opening bracket, and the closing bracket automatically comes because, well, if you've opened a bracket, you have to close the bracket. So R already does that job for you. So it's nice that way. There's lesser chance that you will mess up the closing and opening of brackets. So if you have to use multiple brackets, one within the other, you still go for these curved brackets. So R can only understand these curved brackets in mathematical operations. So if you do have to use multiple brackets, please just use the curved ones. Don't use the curly brackets or don't use the square brackets because these two have separate meanings in R and we will come to them in a few weeks' time. Actually, the square bracket we'll discuss today itself, but the curly bracket we might come up a little later. Okay. So for example, here I want to calculate 3 by 8 first, then multiply it by 6. And then separately, I want to calculate 4 plus 4 and subtract this whole thing from 4 plus 4. Okay. So again, it's always better to use multiple brackets than to end up calculating something wrong. Okay. Again, you might think that for this thing, you don't necessarily need a bracket. You can, even without a bracket, this would be the same thing. But sometimes you can, like, adding additional brackets is never a problem. Okay. So anyway, so if I execute this line, whatever output I get, so this is the correct output. Okay. So R understands that. Okay. Now, so far what we have done is whatever calculations we did, we directly got the output as like on the console itself. We have not saved any of these outputs. For example, let's say if I did 3 into 6, and then if I also want to do 4 plus 9, and if I want to, compare these two things, okay, let's say I'm giving one operation to one student and another operation to another student, then I want to compare which operation gives me the larger number. I need to save the two outputs, right? I can't just have, like, I need to compare them in R. So I need to save them, okay? Now saving means saving the output into something called the environment. Right now, the environment is empty. Right now, R doesn't remember anything. So what we'll do is, so this is the exact same thing that we've been typing so far, right? Something into something or whatever, some operator using some numbers. Now we can assign it to a variable. We can assign the output to a variable. So the right-hand side, we do some calculation and we save it to the left-hand side. So there's this equals to sign. So on the right-hand side, we are calculating, we are saying calculate 3 into 6. And for the left-hand side, we are saying save it to A. Now I'm going to run this. So to run this, I'm again pressing Control Enter. Now what you see here, the line got executed. I did not get any output here, right? For all of these things, I was getting some sort of an output. Now I did not get an output here. Instead, I got something saved here. Now A has the value of 18, which is what we wanted. Another way of doing the same thing is instead of using the equals to sign, there's something called the assignment operator. Now, it can get a little tricky initially, but the assignment operator is always an arrow pointing left. Do not make it an arrow pointing right. It may work, it may not work, but it's better to not do that. So again, remember, you're saving the value which you calculate on the right-hand side into a variable on the left-hand side, right? So this is basically an arrow which is made up with the less than symbol and the hyphen symbol. Okay. Again, both these two things, they do the same task, the assignment symbol and the equals to sign. So if I run line number 22 here, so it's going to do 4 plus 9 and it's going to save it to the variable B. Again, you can see here, it's gotten saved. It's a matter of preference, whether you want to work with the equals to symbol or you want to work with the assignment symbol. They both do the same task. Up to you, okay? Mostly in my command, I think you would see the assignment operator, but equals to would work just fine. Okay. All right. Now, now I have got these two values, right? Now, if I want to calculate a minus b, I can just directly write a minus b. So now you see I did a minus b, and since I did not save this output to something, there's no assignment operator on this line, I directly got an output here. On the other hand, if I would do something like a minus b and I save that to another variable called c in line number 25, I don't get an output here. Instead, I get the result saved into C. Does this make sense? Because these are the very fundamental things that we would use a lot in the upcoming lectures.
Can you please again do it just once more, because
Okay,
I'm finding it
sure.
pretty, yeah.
Okay. All right. So what we are doing is doing some basic calculations.
Excuse
1 plus
me.
2, 5 plus 9. Yes.
Hello. Yes.
Yes.
You have written the hashtag BODMAS as followed. Did you write the script, or it was already there? How did you go over? How did you do that?
Oh, okay. So for example, I can type things here, right?
Uh-huh.
Okay, let me show you something. So when I go to RStudio, I have this file option. I go to new file and I write R script.
Okay.
Okay. So here it gives me a blank sheet.
Okay.
Now I can write here. So as I press enter, I get more lines here.
Okay. Okay.
Now I can say 4 plus 5. I
Uh-huh.
can write 3 minus 2. And I can, if I put a hash symbol here, I can say whatever I want to. So
Okay.
this is a comment.
It's
I can
like a
write-
string command. Is it like a string?
Yes. It is a string. Yes. Yes. Okay. So basically whatever I'm writing within the hash, like after the hash, R just skips over it.
Okay.
R doesn't do anything about it. It'll probably write it directly here, but it's not doing anything about it.
Okay. Thanks.
Right? Yeah.
Thank you.
Okay. So yeah, so then this is what I like. Wait. So suppose this is what I wrote, and if I want to save the script, I can just write like, yeah, file, save as, and then here for this week, I can just save it like trial, and then save it here, and now you see this got saved here, trial.
Okay, got it.
Yeah. Is it a string or work like a? It's just a comment. It's just a comment. Yes. Anything after hash is just a comment. Yeah. Okay. So now back to this thing. So whenever we are typing in some operations, you have two options. If you just want to get the output directly on the console, so you're basically printing the output, so as to say, it's just here on the console. Then it's written directly, like this. Suppose we are writing this thing here. A plus B, 5 plus 9, 2 plus 7, whatever. Instead, if you want to save that output somewhere, if you think you want to do something else with that output, then you save it. Save it into the environment. And how you save it is you assign that value to some variable. You say, save the output and call it A. Save the output and call it B. Save the output and call it A, B, C, D, whatever. Okay. So that's what we are doing here. So what we did was we said, calculate 3 into 6, and then don't write the output in the console, but instead save it to the variable A. So that's what we got here. Then we said, calculate 4 plus 9 and save it to the variable B. And then we got it here. And then we said, okay, now we've got A and B. Now subtract B from A and just tell me what the output is. So when we did that, it said, okay, the output is 5. And now if you want to save that output 5, we'll say, okay, do A minus B and then save it to the variable C. And we've got it here saved. So then again, we have C here. So now we can do something with C also. We'll do that somewhere, in the next few lines. Two things very important, that space does not matter in R. So you can see here I have put no spaces. right? But here in this line, I've put some spaces before and after the assignment operator. Okay, I could have added a space here. I can add a space here, or I don't need to add a space here. So adding extra spaces or removing spaces does not matter. It's again your preference, your choice, how clear you think it makes when you use or when you don't use a space. Okay, so that's up to you. And the other thing is R is case sensitive. So it means it treats upper and lower case or capital and small letters differently. For example, here we have a variable A, which is a small a. Now, if I say save 100 to capital A, then you see I got A. It's a different thing. It did not overwrite anything. I have two different variables, A, like small a and capital A. So be very careful about it. Okay. So no issues with using extra spaces in R. And R is case sensitive. Okay. So now here what we did some of the 5 very basic operations, right? Plus, minus, multiply, divide, and power. Power is also basically multiplication, right? Now, there are some inbuilt functions in R. So when we say function, we mean something which looks like this. So there is a word which sort of explains what the command is going to do. And then there is again this curved bracket that we talked about. So we have talked about curved brackets in 2 places. One, where you want to separate some maths from somewhere else. Okay, the usual use of these curved brackets in maths. The second use of curved brackets in R is when we are dealing with functions. So we'll see what they're doing. Now, if I say I want to find out the square root of 81, I have 2 ways of doing that. One, I can do the basic thing, which is, so anything to the power half will give you its square root. Okay. So I can run this directly. I can say 81 to the power 0.5. I could have also written it this way, 81 to the power of half, right? I can do that. So 81 to the power 0.5 gives me 9 here. 81 to the power half also gives me 9. And there is an inbuilt command in R. There is a function in R, which is called sqrt, all in small. And if in bracket I write, so in the bracket I have to write what number's square root I want to find. So if I say sqrt 81, that also gives me 9. Okay, so you have multiple ways of doing the exact same thing. Again, whichever you prefer, but they're all equally correct. Okay. So this sort of a notation is something we'll use very, very, very often. Okay. So whenever you see some alphabets which are followed by a bracket, now there's not going to be any space in between these. So name and bracket, they come right after one another. So if you do that, then this means you're using a function. There are a lot of functions, like tons and tons of functions available in R. And of course, you don't have to use everything. So we'll use them as we need to. So we've seen square root, sqrt. Now, if you want to find the sum of, let's say, 5 numbers, okay? For example, if I want to find the sum of 60 and 21 and 30 and 40, if I want to do that, I can do this, right? 60 plus 21 plus 30 plus 40. If I do this, I get 151. So I'm using the plus operator multiple times. Instead of that, what I can do is, I can say, I can use the sum function. That's an inbuilt function, inbuilt command. And in the bracket, rather than using the plus symbol, I'll just use commas because these are different entries. I'll say find the sum of 60 and 21 and 30 and 40. If I do that, again, I get the same answer. Okay, again, 2 different ways of doing the exact same thing. I can also find a product of all of these numbers. So if I want to find the product, I use the asterisk symbol, right? And I'm executing this now. So I'm pressing Control Enter here. Oops, sorry. So yes, so this is what I get. And instead, Yes. So instead, if I use the product command, which says that find the product of these 4 numbers, I also get the same thing. Okay. There are some more. So again, there's no limit to how many such functions there are, but the way to go about this is soon, like with practice, once you do a lot of these, once you write a lot of commands, you will come across more and more. Maybe you'll search the web. Maybe we'll discuss these in these courses. Or if you think, you'll get an idea, maybe there should be a function to do something like that. Then you can always search it on Google and then you'll come across, oh yes, this function does that job. So then, again, another function. So this ABS, this stands for finding the absolute value of a number. Absolute value means for positive numbers, it's that number exactly itself. And for negative numbers, it's that number without the minus sign. So if I say ABS of minus 134, it's giving you 134. So what is happening in these functions or in these commands is inside the bracket, it accepts one or more inputs. Now, these are called arguments. Okay, we'll call them arguments, we'll call them inputs. And sometimes the order may be necessary. Sometimes the order may not be necessary. For example, when you want to find sum and product, obviously it doesn't matter what order you put them in. Okay. Some cases the order matters. We'll see those examples soon. For example, numbers like absolute, well, you only need to enter one number at a time. Okay. We will deal with multiple numbers soon, and we'll see how to use those with some of these functions. So again, the next thing that I've written here is storing values in these variables, or you're assigning values in these variables, right? What we did a little time back. Up until now, what we've done is we've just saved one value to one variable. So A just has the value 18. Capital A just has the value 100. Small b just has the value 13, and so on. Okay. Again, there are lots of, I've written some of these things just to sort of summarize what we have discussed so far. You can use the equals to symbol, you can use the assignment operator, any bracket you use, whether you use it for maths or whether you use it for these functions, it'll always have a closing and opening thing, like opening and closing brackets. Yeah, another thing. So let's say when I was typing product, when I type PRO, you'll see RStudio, also R both, they give you some options that, oh, maybe this is what you are looking for. Okay. It doesn't always do the best task, but it gives you a possible list of all things you might be going to type. And this is very important because you don't want to mess up, especially when you're typing on a computer. You don't want to mess up with the spelling or whether it's capital or small, or because you will see examples where this one letter is capital and everything else is in small. Okay. For example, you can see here some examples. Some one letter here and there is capital. Very often you may get confused in that. So what R does, once you have typed 3 letters, or you can also press this tab symbol. So it's going to predict what all things you might be about to type, and then you can choose, and then there's a good chance you will not make any errors. Okay. So something like that. Okay. So R can give you suggestions when you've typed 3 or more letters, or if you've just typed 1 or 2 letters, you can just press the tab key and R will also do the same task then. Okay. So far we have talked about one value, one letter. Sorry, like one variable, one value. But you can also save multiple values into one variable. Okay, for example, let's say, very simple example. Suppose you want to save the marks of 30 students in a class, right? You have those 30 values with you. Well, you don't have 30 alphabets, right? That if you save them as 1, 2, 3, 4, obviously you can call them maybe A1, A2, A3 up until A30. but that's still a lot of work to manually, assign them each variable. But instead, you can save them in just one variable and then order them in the right way. So let's say one variable has 30 values, but the order in which those 30 values appear is, let's say, their roll numbers. Okay. So those such examples are called vectors. Okay. So we'll see how we assign. There are 2-3 different ways in which you can assign vectors. The first thing is using this C function. Okay. Now, what we discussed about something being a function is when you have some letters. Here in this case, just one letter, but okay, it's a letter anyway, followed by the curved bracket. So this entire thing, this is a function and it stands for the combine function. C is short for, it's used for the combine function. So what we are doing here is, again, we are saying C, and then within C, we are typing some numbers. So here I've typed the first 5 odd numbers. So 1, 3, 5, 7, 9. Again, just an example. And I'm saying save it to the letter L. So if I execute this line, now you see what's happened here is, again, I've got the variable L, and now it has 5 values. It says NUM, which stands for numeric. So R is identifying that L is a vector. So this sort of a notation. Now we have come up to the second bracket, okay? The square bracket. This sort of a notation indicates that you have 5 values stored in this vector. L is a vector which has 5 values. All the 5 values are numeric. And these are those 5 values. Does this make sense? Like, are you able to read what this line is trying to tell us? Yes? Okay, great. So now, for example, imagine these were 5 marks of those 5 students, and this is their roll numbers. Okay, so like the first student, then the second student, third student, fourth, fifth. The order is essential. Now, what you can do is you can access one of these values, you can access 2 of these values, you can access all of these values. If you want to access some particular values, you need to make use of the square bracket. Now, the roll number that I talked about, 1, 2, 3, 4, 5, think of those as positions or indices. Okay, these terms you might have come across if you have had any other programming experience. If not, no problem. The positions basically of each of these values are also referred to as the index or the indices of the values. So for example, the first value here is 1. The second value here is 3. Third value is 5. Fourth value is 7. And the fifth and the last value is 9. Now, okay, I already have the answer written here, but for example, if it's not there, what do you think this will tell us? What would you get if I execute this thing? So it says L, and in square bracket, I say 4. What do you think the output here would be? It's okay if you're wrong, but give it a go. You can unmute yourselves or type in the chat. 7? That's perfect. Yes? So what this command... Yes, it's 7. Correct. Yep. Good. Yeah, that means you're all understanding this, which is nice. So yes, so what we are doing is that it says, okay, access, like give me the fourth element or the value at the fourth position or the fourth index. So that thing is 7. Okay. Now we'll do a few more things here. Let me do this thing first. Okay. Now, can you maybe guess if I run this command, 6:10, what do you think I would get? I'm just shooting random questions right now. Yes.
7, 9, 7, 9.
Okay. Yes. Yes, perfect. Okay, let me first go to the comment here. So very good observation. And sorry, I did not clarify this. Yes, the index in R does not begin with a 0. In Python, the first element has the index 0, but in R, it's very simple. First index is 1, second index is 2, last index is the last position. Yes, so good observation, and thanks for pointing this out. And yes, the output for this thing here. So now, I'm sorry, I forgot, like I did not see who answered with their, who unmuted their mic. But now this thing has nothing to do with what L is. L, which is a list of these odd numbers. Here, when I'm saying 6:10, it has nothing to do with that L. Okay, because I've not written L in that line. This is an independent statement. And just like one of you correctly wrote in the chat here, that 6:10 means list down everything from 6 to 10. So 6, 7, 8, 9, 10. Okay. Likewise, if I would have written 10 to 6, it would give me the opposite thing. So it says 10, 9, 8, 7, 6. Now, why I have written this here is, now I'll combine the two things. Now, if I say L 2:4, now can anybody guess what this might do? Okay, it's a 2-3 step answer, but can anybody give it a go, and then I'll explain what we are doing here.
It will give second to fourth observation.
Perfect. Yes, second to fourth. So it will not give second and fourth observation. It will give second, third, and fourth, because colon here says everything between. So 2, 3, 4. Right? Like slicing. Oh, perfect. Yes, that's a very appropriate word. So when I say 2:4, it says, so it's basically the same as saying 2, 3, 4. And it's saying that give me everything at the indices 2, 3, and 4 in the vector L. And that is 3, 5, and 7. So that's what I get, 3, 5, and 7. So you've basically made a shorter vector out of this longer vector, and you can call it slicing. That's a very good term. I really liked it. Okay, perfect. Again, it is not very trivial. If any of you is looking at such cases for the first time, it can take you a while to understand. Please feel free to ask questions. And the best way to get around this is practicing it yourself. So open R or RStudio and type in these random commands. Okay, this is just a few questions I made up. And then try to see what answer you get, and maybe and then try to rationalize what is it that R is actually trying to do. Okay, and then soon you'll get a better idea. So the vector works on negative numbers. Okay, good question. Very good question. Now, indices cannot be negative, but the vector values themselves can be negative. For example, let's define another vector. I'll call it M. And let's say, say it has 2 and -3 and 6 and 9 and -1 and maybe -5. Okay. Again, I have put a lot of spaces here. It really doesn't matter. It's just your choice. So I have this vector with me. I'll execute this. So now this vector is available in the environment. It's a numeric vector. It has all these numbers. It has 6 elements. Now, if I want to access, let's say, the second element, if I write M and in bracket I write 2, it just gives me -3. If I say give me vectors 1, like give me from 1 to 4, it gives me this. Now I have another question for you. What if I write this? What do you think would I get here? Again, not easy, but take your time and tell me what do you think I would get as the output here. And Madhuram, did I answer your question about how do vectors work on negative numbers? So your indices can't be negative, but vectors can be The values can be negative. Okay. So
-3, 6, and -5.
perfect. Yes. So again, so anything that I write within the square bracket means that we are dealing with the indices of the element of the vector here. So what we are dealing with is we are dealing with the position number 2, position number 3, and position number 6. It doesn't matter whether 2 was itself a part of the vector. I just use these numbers to confuse you. But basically we are saying what's present at position number 2. So that's -3. What's available at position number 3? That's 6. What's available at position number 6? That's -5. So if I run this, I get -3 and 6 and -5, as one of you rightly said. Okay, so it's very easy to get confused here, but please give it a go. Try this out yourself few times. You'll get better at this. Okay, and let me know if there's any question. But yeah, it's really fun to try out these random questions. Okay, so we've done two things here. Now you see, okay, let me give you one more example actually. So again, we made up this vector, right? Let me just put it up here. So we did this vector, right? 6, 7, 8, 9, 10. And here, I could also have done it like this. So if I say 10 up until -5, I get all of these numbers. Now, yes, these numbers, I do have some, like, we can have like lots of examples here. But let's say I do this. Can you guess what might be the output here? I'm saying 5.4 to 8. What do you think?
Ma'am, number between range the 5.4 to 8 number.
Yes. So what do you think it
of
would
the
be?
range.
Would it be 6, 7, 8? Would it be 5.4, 6.4, 7.4? What do you think?
5.4, 6.4, 7.4.
Good, good. Yes. So colon always adds 1 or subtracts 1 depending on which direction you have to go to up until the end point. Yes. So 6, 7, 8 seemed like a really good answer. But again, these questions are all meant to confuse you. So the starting number is always the first one here. And then you are adding 1 or subtracting 1 going into that direction. And you're stopping before the end number comes. So 8.4 doesn't come up here. Okay. Now, finally, you can also save this thing directly to a vector. So let's say I have a vector D and I can say that, okay, save this thing here. Right? So, yeah, so you can see this vector D. So we have already seen two ways of making vectors. One is the C command and the other is this colon command, right? So two things. Now we'll take the third example. So there is a function called seek, in short for sequence. Sorry. So what the seek function does, again, there's lots of things we can discuss, but it'll be beyond the time that we have today. So I'll walk you through a few things. So there are basically 3 inputs that you have to give, 3 arguments. Remember we talked about arguments initially, that each of the things you are writing within these brackets, these are arguments. In some places, these arguments have a particular value, a particular order in which they need to come. In some places, these arguments have names. Yes, perfect. That's a very good question, and we will talk about that today. Vectors can definitely be dealt with mathematical operators, and that's a very important thing for week 1 assignment also. Okay, so yes, we will talk about it. Okay, so now again, you see what we talked about a function. You have a word here, seek. You have these 2 brackets here, and there's something written inside. Now, there's one very good functionality in R, and I would really recommend you using that. So in the console, you can type question mark, and then you can write the name of a command. It gives you all these options. I just write seek here. and I press enter. And here in the bottom right, and there's a help page opens up, which gives you some explanation about the function. Okay. There's a lot of things. Not everything is very important, but it gives you a good idea of what you're working with. So give it a try if you get some time. That what we are working, because I'll not be explaining everything, but what I explain is going to be enough for you to understand for based on like what you needed for today's session. But for a better understanding, not just now, but even later, if you work with R, using this question mark and seeing the documentation of what R has to say about that function is really helpful. Okay, so basically what I'm doing is if I want to make a sequence. So for example, we saw this example here, right, from 5.4 to 8. So what we are doing here is we are going from 5.4. We are going from 5.4 to 8 in increments of 1. Likewise, in here, we are going from 10 to 6 in decrements of 1. Here, it's always plus 1 and minus 1. What if you wanted plus 1.5? What if you wanted minus 3.2? So for that, you can use the seek function. Again, what you need to tell is 3 things. You say, where do you want to go from? Where do you want to go to? And by how much? In what steps? So I say I want to go from 1 to 10 in increments of 2. Or I want to go from 100 to 1 in decrements of 2. So decrements has to be this like minus symbol. Again, what we are doing is, so let's say I do this from 1 to 10 by 2. I get the exact same thing. You see how we had written 1, 3, 5, 7, 9. We had written this like 1 by 1. Now we got that directly. Okay. So that's another way of doing the same thing. Now if I execute the next line, now you see what happened. I get 198, so on and so forth up until 2. I don't go down to 0 here because that would be lesser than 1. And I say just go up until 1. Is this making sense here? Yes, this step value is just yeah. So again, it doesn't have to be whole numbers. So if I would have written that from is, let's say, 30.5, and if I say 2 is minus 40, and if I say by is equal to minus 2.7, it'll give me, so it's basically saying 30.5 minus 2.7, then minus 2.7, minus 2.7, so on and so forth. So it's just doing plus or minus and giving you a vector. Okay. But yeah, it's just a matter of understanding. But yes, what you're saying is correct. Okay. Now, can anybody tell me, in wherever I've been getting these outputs here, I've always seen this square 1 everywhere at the beginning of each line. Now, when I've had multiple lines here, I'm getting different things starting here, some different numbers in these square brackets. Can anybody guess what these numbers are indicating from what we talked about square brackets? So square brackets generally has something to do with indices, something to do with positions. What do you think in the output? What do you think these square brackets are telling us? Pointer position, correct. Okay, so for example, this is the first value. Then second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then this is the 18th value. So it says 18 at the beginning of that line. Then we go blah, 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 blah. This is the 35th value. So here it says 35. In this line, because you have a decimal, you can't save as many numbers in that line. So this number here, this is the 12th number in the output. Now, now what I'll do is I'll just expand this console here and I'll execute the same line again. If I want to execute the same line again, I'll have my cursor here in the console. I'll press the upper arrow key and I can go back to my previously typed in commands. I can press up and down and go back. So what I'll do is I'll type this top command again And now you see here, since I increased the width of the output window, I can print more numbers now. So now this number here, this is the 16th number. Okay. Anyway, so you don't have to get confused by what these square numbers are. This is just to give you a better sense of how the output is arranged. Okay. First position of that line. Yes, exactly. Good. All right. Great. Now we have dealt with, basically we have dealt with single value variables and vectors. So let's use some more commands now. Let's use some more functions now. So we are already more than halfway through the time. So I think we should be able to finish it. There's not a lot to do. Okay. Now here in RStudio, you can already see on the right, for whatever variables we've saved, you can already see on the right the length, right? It says 1, 2, 3. So it means this length is 3, this length is 5, this length is 6. But let's say if it was for something like this, right? You don't want to count 1, 2, 3, how many elements there are. So there is a function in R called length. So you say length, and then in bracket, you write the name of the vector. So if I do that, it says the length of the vector L is 5. Now, can you tell me if I want to find out the length of this vector? I've not saved it yet. This last vector that we just executed, which is on line 78 right now, I've not saved it into anything. But if I want to find out the length of this, how do I calculate that? Like, of course, I can save it into a variable. I can call it, let's say, Z, and then say length Z. But what if I don't want to save it? Is there a way out?
Ma'am, can you repeat the question, please?
Okay. So this is the vector, right? I've not saved this vector anywhere. Like, you don't see this vector in the environment. If for the vector L in the environment, I could do length L. But the vector here on line 78, it's not saved into the environment. I've just printed it here. But let's say I do want to calculate the length of this. What command can I write? Okay, I'm just trying to confuse you. It's not.
len of sequence, length of sequence.
Yes. Okay. So I'll just write length, and in bracket, I can just copy the whole thing. So I'll just copy the entire thing here. So now you see there's a function within a function. So this is the bigger function. And then if I put my cursor here, you can see this opening bracket and this closing bracket get highlighted. And then here there's the inner function, which is actually making the sequence. And then there's another opening and closing bracket here. So if I execute this line 83, I just get the value 27. I no longer get the entire vector, but I just get the final value, length of that vector, length of this vector here. So,
ma'am,
yes.
I have a question. जब हमने ये सॉल्व किया तो मैम हम इधर लेन का शॉर्टकट भी यूज कर सकते हैं, मतलब सिर्फ एलियन भी यूज कर सकते हैं, मतलब जैसा हम पाइथन में यूज करते हैं एलियन, सेम वैसा भी यूज कर.
हाँ, so R में there is no function len. len function नहीं है कोई. Length is a function. हाँ. So good question, definitely good question. But yes, so depends. Like there is, of course, some differences are there between different languages. So it gets difficult. Sometimes you can get confused. So which is why that tab function is very helpful. Because you see, oh, len karke to kuch hai nahi, but there is something called length. So now you know you have to use the entire word. Okay, great. Now we come up to what one of you were asking, if we can do some mathematical operations using vectors. So we will take a few examples here. So what we did so far was basically making and defining vectors and then seeing what the lengths are. Now we're going to make these 4 more vectors. Okay, I'll execute all of them together. So I've highlighted all the 4 lines. I'll press Control Enter. So all of these got executed, and you can see here we've got these 4 vectors, A1, A2, A3, A4. And so for the first one, it was just using the C function. So we've got these 6 numbers. The second one, again, we have just used, if this was using C, this one is using seek. The other 2 are also using C. Anyway, the thing is that we now have 4 vectors. The first vector is of length 6, second is also of length 6, third is of length 3, and the fourth is of length 4. Okay. Now, whenever you want to do, suppose it's like, okay, you want to add up vector 1 and 2, or you want to add up element wise. So what you want to do is say 4 plus 1, 5 plus 2, 6 plus 3, 7 plus 4, 8 plus 9, 8 plus 5, 9 plus 6, something like that. When you want to do this, so it makes perfect sense for A1 and A2, right? Because it's happening element wise. First element with first element, second with second, last with last, sixth with sixth. So there's no question, there's no confusion, no error, nothing. You can do plus, you can do multiply, you can also do divide, you can do subtraction, right? Right? You can do all of these things. Now, what if so now let's say I want to do A1 and A3 and A1 and A4. The thing is, now if I say, okay, if I'm adding up, so 4 plus 0, that's fine. 5 plus 3, that's also fine. 6 plus 5 is also fine. But now what about 7? What would happen with 7? Okay, so remember A1 and A3. First element, second element with second element, third with third, but there's no fourth element in this. So what would happen here? What do you think R is going to do? Like, would it be able to calculate it? Would it say, no, not possible, you're doing something wrong? Any guesses?
मैम अगेन वो 0 से ऐड करना स्टार्ट कर देगा 0 फिर 3
Correct.
फिर 4
Yes, exactly, correct. So, यहाँ पे इसने what it did was, it did 4 plus 0, so it gave you 4. Then 5 plus 3, it gave you 8. 6 plus 5, it gave you 11. Then what it did again, 7 plus 0, 7 दे दिया. 8 plus 3, 11. 9 plus 5, 14. So, it calculated everything. It did not give any warning also. It did not give any error also. It did exactly what you just said. Yes, exactly, right? So the reason was that here we are dealing with 2 vectors. One has a length 3, one has a length of 6. 6 is a multiple of 3. So this smaller vector could be repeated completely, right? You had first 3 elements and then again this was repeated entirely. Now, what if I do the same thing, but I say element A1 and A4? Again, 4 plus 2, it'll work. 5 plus 5 also will work. 6 plus 8 will also work. 7 plus 0 will also work. But then for 8, like what we just saw, 8 ke liye it would start again with 2. And then for 9, it'll again start with 5. But then the entire vector 4 was not repeated. Part of it was repeated. Part of it was not repeated. So it will give some output. So you see here, output diya. 4 plus 2, 5 plus 5, 6 plus 8, 7 plus 0, then again 8 plus 2, 9 plus 5. Output diya. But it also gives you a warning. What warning it gives is the longer object length, which is 6, is not a multiple of the shorter object length, which is 4. Right? Make sense? Yeah. So ideal case में only A1 and A2 के साथ काम करना is good. Like working with 6 elements and 6 elements is what you should be working with. Working with 6 and 3, maybe it's not the best thing. R did not give you any warning. R did not tell you that something funky is happening. It gave you a warning when you were working with 6 and 4 lengths. But so whenever you're working with vectors, it's your responsibility to check if you're working with the same lengths. R does not automatically do it, but it's better if you check it. Okay. Then this thing we already saw, right? Accessing one or more specific elements of a vector. We've already seen this, so we will not go through it again. And yes, these are the three brackets that we've talked about. The curved bracket, we've already seen. Curved bracket, once we use it for mathematical operators, we also use it for these functions, see, seek, length, prod, sum, all of that. And the square bracket, we've seen it when you want to access particular elements of vectors. And you've also seen the square bracket in, the first position of each line in the outputs. Curly brackets, we'll work with them a little later, not today. Okay. There are some more inbuilt functions in R. We saw sqrt already. We saw C already. Some of these you might come across. I don't remember entirely if it was week 1 or week 2, but you might come across some of these in week 1 or week 2 assignments. So anyway, again, these are very explanatory. So, okay, so let's quickly walk through something else here. So we'll talk about two functions here, max and mean. So max, obviously, it means you have to find out the maximum value. Mean, it means you have to find the average. So, okay. Now what I've done here is, for example, maybe we don't need this right now. Okay. Now look at these two examples. Do you think, so can anybody explain me what is the difference between line 108 and 109? Any guesses? What do you think is the difference here?
मैम आई थिंक 108 में जो है वो वेक्टर फॉर्म में है, और जो
हाँ
उसके नीचे 109 में है वो उसमें दिया गया है कि इसके अंदर मैक्सिमम वैल्यू कौन है वो फाइंड करने के लिए.
Correct.
So-
Okay. Yes, absolutely right. So 108 में there is just one input to the max function. That input is a vector. 109 में there are 4 independent inputs. Each of them is a single value. So it's just a matter of how you're writing it. But it looks like both of them should do the same thing. So let's try. So if I execute both the lines, I get 4. So both the lines are doing the right thing. Fine. So whether you're inputting one vector or whether you're inputting 4 small values, they are doing the same task. Now, it seems the mean should also do the same thing. The mean should say, okay, whether it's one vector or whether it's 4 independent values, it should still do the same thing. So if I execute this first line, I get 2.5, which is the mean of these 4 numbers. 1 plus 2 plus 3 plus 4 divided by 4, that is 2.5. So this is fine. But now if I write this thing, if I say mean of these 4 numbers separately, it just says 1, which is incorrect. So what is happening here is mean is absolutely ignoring the next 3 numbers. It's just taking up the first input and it's calculating the mean of the first input. So mean of 1 is 1. Likewise, if I run this line here, it's saying mean of 3 is 3. It's just ignoring all the next numbers. So basically what this is telling you, that inputting as a single vector is better than inputting individual numbers. Okay. This is not absolutely essential for you to take care of right now, but these things come with practice. Okay. Similarly, for the sqrt function, so when you're working with one vector, it's able to find out the square root of each of the elements. But when you're inputting 4 values, it's saying 4 arguments passed. You remember we talked, it's called argument. Inputs are called arguments. 4 arguments passed to SQRT, which just requires 1. So SQRT can take up only 1 input. Now that single input can be a single value, or that single input can be a single vector. Does this sort of make sense? I know it's not very easy, but just visit this once more and then it'll get clear. So the conclusion from this bit is, if you have to work with multiple values, combine them into a single vector and then use it. It's always better. It's foolproof. It won't give you any error. Okay. Now there's this one function called plot. Okay, so plot, basically you're all familiar with, you make these scatter plots, right? You have an x-axis and a y-axis, and then you make points. So each point is telling you this point has a particular value for x, this has a particular value for y. So each point has an x and y value. So therefore, we are working with lists, oh sorry, not list. We are working with vectors of the same length. For example, let me define 2 vectors here, x and y. Both of them have the length 10. Okay. I defined one of them using the C function, one of them using the colon function. Now, if you want to make a plot, so here the bottom right is where the plot is going to be generated. So I'm just increasing that. If I just say plot x comma y, so you see this is what I got. I can zoom it and we can just look at it better. So you see the x values were ranging from 1 to 91. So you can see here. And the y values were ranging from 101 to 110. So this is what we got. That's a basic XY scatter plot using the plot function. So again, plot function, you have a word followed by bracket and you have 2 arguments. Now, of course, it's very important, the order. So if you write y comma x, it looks similar because they're both increasing, but you can see it's swapped. Now, the x-axis here is 101 to 110, and the y-axis here is from 1 to 91. So here the position of the arguments is important. Whatever you write first gets plotted at your x-axis here. It's being called y because that's the name we've given it. Don't get confused by that. So whatever the first argument comes at the bottom and the second argument comes here in the vertical thing. Okay. Now this is a very basic plot. There's no colors, nothing written. So if there's another argument you can write, which is called main, it's a named argument. If you do that, then that becomes the title of your plot. Okay. There are different types of plot. So by default, this was a point plot. You just had points here, right? That's with P. If you just write P here in double quotes. Again, I'm walking a little fast right now because there are a couple of things I have to finish before the end of the session. But again, you'll have the script with you, so don't worry. We'll be able to, so you can walk through these again. If you write L, then it just gives you a line connecting all the points. If you write B, then it gives you both line and plot. So B stands for both. S here stands for step. And H here stands for the histogram. Again, what you can do here is you can use the question mark plot command. And then here, here you can just click the first thing and it'll tell you what lots of things are there that you can actually do with the plot command. So you see here this type thing. So L for line, B for both points in line, C for, O for overplotted, S for steps, H for histogram, and so on. Now, this plot, you can click on export and you can either copy to a clipboard, save it to a PPT. You can save it as an image. You can save it as a PDF. Also, all of those options are there with you. Okay. Yes. Now this is very important. Relational operators. Okay, are we good until now? Because we'll just quickly switch gears and discuss two
मैम
more things. Yes.
मैम एक्चुअली मुझे एक डाउट था एक्चुअली असाइनमेंट जो 1 था ना अपना एनपीटीएल का, तो उसमें लास्ट का क्वेश्चन प्लॉट का था। तो मैंने उस टाइम जब मैंने ये सब जब सॉल्व करा था उसका असाइनमेंट, तो उसका आंसर ही नहीं आ रहा था, लास्ट का आंसर ही। मैंने बहुत बार ट्राई किया सेम कमांड से, तो उसका आंसर नहीं आ रहा था।
Okay. So what you can do is, if there are any specific questions with regards to the assignment, definitely put it on the discussion forum, because there is another TA who is setting up the assignment questions. So they will be the best person to talk to about the assignment. I will definitely be discussing those assignments here once they are solved, but not before the assignment deadline. Okay? So here you have this.
And ma'am, when we get results of assignment, our assignment, when we get results of our assignment.
So उसमें deadline लिखी हुई है, like for the assignment 1 the deadline is 5th of February, so you will get the solution on 6th of February, next day.
Okay, ma'am, thank you.
Okay, all right. So now for relational operators, basically you are comparing numbers, and of course you can also compare vectors. So, and this will give you an output of true or false. So remember, we talked about R is case sensitive. So the true and false that we are talking about here is always capital. Capital T, R, U, E, capital F, A, L, S, E, or just capital T or just capital F. So whenever we are making these names of these variables, never use capital T or capital F here, because they are sort of reserved words. Okay. So if you want to say 5 greater than 9, oops, sorry. Yeah. If I say, I'll just clear this thing here. Okay, I'll just clear this up. Yeah, okay. So if I say 5 greater, what's happening here? I'm really sorry about this. I think I need to check this. But anyway, so 5 greater than 9, it's saying false, because of course. Then 5 greater than equal to 9, also false. 5 less than 9, that's true. 5 less than equal to 9, that is also true. Now, if I just write 5 equals to 9, it gives you an error now. Because what is happening, it's saying that you're assigning 9 to 5. 9 की value to 5 nahi hai, right? So when you want to compare if something is equal or not, you use a double is equal to sign. So 5 equal to 9? No. And this symbol here means not equal. So 5 not equal to 9, that is true. And again, you can also do it with variables that you have saved. So if I say B and C here, so B greater than C, what will this say? Like if I write B greater than C, will it give true or will it give false? Line 147, true. And then A greater than B, so A is 18, B is 13, so that will also give true. Okay, yep. Okay, now, you might have read about gates, OR gate, AND gate. So there are these 4 things. So you can work with multiple true and false statements. So true and true, if both are true, then the output is also true. If one of them is false, then the output is false. Okay, so true and true give you true. True and false give you false. False and true also give false. And both false also give false. So whenever you have this AND operator, this ampersand symbol, both have to be true, and only then will your output be true. Both conditions are being satisfied. And when you're working with the OR statement, just one of them being true is enough. So true and true is true. True and false is also true. False and true is also true, but both false give you false. So we'll not talk about the double ampersand and the double OR right now. We'll take them up in a later class if needed. You don't have to worry about that at all. So I'll just remove it for now. So we're just working with this is basically and this is OR. So this AND symbol is you have above number 7 on the keyboard. And this symbol is also called the pipe symbol sometimes. That is just below your enter, just above your enter key on the keyboard. Okay. So yes, so now anybody, can you think what is happening here? What would be the output here? Yes. Yes, this is going to be false, correct? Yes. So what we're doing is, so 9 greater than 0, that's true, right? And 5 greater than 9, that's false. So you have a false statement and a true statement. So false and true give you false. Whereas here it's true and true, so the whole thing will give you true. Again, these might just appear like random things right now, but as we build more and more commands throughout this course, you'll see how these statements can be used. Okay, now just final 2 things here. There was this sample command, I think it was used in this week. So for example, if I just say sample 1 is to 100 and 5. So what this is doing is, from between numbers 1 and 100, you give me randomly 5 numbers. Okay. Okay. Yeah. Okay. All right. So now when I say sampling replace true and false, this is not like it won't make a lot of difference maybe in these examples. But so basically it's like, so you have let's say you have a big bag which has, you have 100 balls, each with like a number written on it. And if you're picking, let's say you picked one ball and let's say what you got was number 65. So if you already put that ball outside, you can never pick number 65 again, right? But if you put back that ball and you shuffle it and then you pull out another ball, you've basically replaced it, right? So replacing true or false, it just means whether those numbers are still there or not. Again, this is more to do with why are you doing these random samplings? But from the purpose of R, what these lines are telling you is that this is like this extra argument in this command. And you can see here in the documentation that here by default, the replacement, this command by default says that it's without any replacement. If you've picked 65, it's outside the box. You cannot select it again. Okay, again, this is slightly random right now, but we'll use it sooner rather than later in the course. Okay, now the final thing for today is, right now, when you install R in your computers, these commands that you see, sample, max, min, square root, things like that, this is something that all of us are going to use, right? Irrespective of whatever field we may be from. These are some very basic commands that would be useful to us. But there are some commands which are very field specific. For example, I do some bioinformatics. So there are a lot of things which are just specific to bioinformatics. Okay. Some of you might be from the field of economics. So maybe there are some functions which are specific to that field, and it may not be of any use to me. So these commands, so I don't need to install everything on my computer and just have it, sit without any use. So I have installed a lot of things on my computer, but I'll only use them when needed. And I have not installed a lot of things on my computer at all. If I need to, I'll install them then. So it's a two-step process. The things that we have used until now, they are available in the base package. So you'll see here, everything we've used until now comes from the base, which is already there on your computers once you've installed R. But if you want to use some new functions, you need to first install those functions. And these functions are actually bundled together as some packages. So you can install that entire package and then use all the functions that are there on that package. So the first step is to install a package. For example, there's this function, there's this package called Painter, and I can install that. So the command I would write is install.packages, then I'll have a curved bracket, and then within double quotes, I'm going to write Painter. Now, when I am doing some installation, I need to be connected to the internet at that time. Otherwise, I don't need to be connected to the internet when I'm working on R. Okay. So if I run this line here, so you see what it's going to do is, it says trying, okay, it was very quick, but it said trying this URL, doing something, this is the size, it downloaded this thing, and the downloaded things are kept somewhere on your computer, and that's it. So now, in RStudio, you can check what all packages you have. So if I go to this packages tab, you see, for me, there are a lot of this is installed here. But you see, there's not a tick mark on all of them. Now, this list would look different for you, but you will see that most of the things don't have a tick mark. For example, let's see this Painter package. So this is arranged alphabetically. We'll go to P here. Yeah, so you can see Painter is now installed. So it shows up here, but there's no tick here. So even though this Painter package is available on my laptop, I cannot directly use it. So I want to call that package or load that package or load that library. So the function I'm going to use is library. Mostly, so installation is a one-time process. Once I've installed Painter, it's there on my computer now. So I can use it as many times as I want. But so I have all of these packages installed on my computer because I've used them some or the other time. But every day I don't need them. So again, there's no point in calling them every time I'm opening R. I'll only call whatever I need. So today I need the package Painter. So I'll just call that. So to call that, I'll use the function library. So library, and then within bracket, I write the name of the package. If I run this, it just runs. Normally you don't get any output here. But what you can see here now, now you see there's been a tick here because the Painter package is now available for you to use in this R session. All right. So there's this demo function. It gives you a good job. It does a good job of giving you a demo of how, let's say, the graphics function works. So demo, it gives you a lot of these things. Again, we're not going to go through it, but demo can just tell you what all the graphics package has to offer. So you keep just hitting enter and it does a lot of these things. Yeah, okay, fine. It did save a lot of things into my environment. So I'm not particularly a fan of that. But anyway, demo function just basically tells you what the function can do. Yes, okay. Just give me 2 minutes. I'll share the link with you. All right. And then if you want to if you want to remove something from your environment, because now there's a lot of things. If I hit RM is short for remove, And if I just write RM capital A, so it should just remove this variable here. If I write RM completely, it would remove everything. So use the RM function very carefully. I will not recommend using it, but yeah, so that's it. So that's everything that we discussed in this week. There's just one final thing before we end up today's session. So, for example, we don't exactly have a lot of practice questions today, but you see, along discussing the course, like while we had that our studio opened, we discussed a lot of questions, right? So those questions are definitely going to help you answer week 1 assignment. Assignments in week 1 look very much like this. So now you should be more familiar with what each of this is doing. So for example, X is assigned as 32, Y is assigned as X to the power 3. So you have to do 32 into 32 into 32. And then Y minus X to the power 4. So now, obviously, you can use a very basic calculator for this, or you can directly use your R console. What I would recommend is, rather than writing the output using the R console, try to manually solve it and then double check it using the R console so that you would understand how R is actually dealing with these statements. Yes, just give me 1 second. I'll tell you about the video and the Google Drive. Right? Same is the case with this. So our X is assigned as -9, X to the power 5 minus X to the power 4. You take the absolute value of that and then you find the square root of it. You save that into Y. And then Z is -X minus Y. You can calculate that. There would be some commands which look like this. So here you're working with vectors. So it's a 4-element vector. You divide it by another 4-element vector. You multiply another 4-element vector. You find you do a power with another 4-element vector. And I'm missing a bracket here. Sorry. It's going to be like this. Yeah. Right. And then you plus 3 into another 4-element vector. So yeah. So this thing, if I didn't clarify, this line would just mean 3 into 121, 3 into 211, 3 into 132, 3 into 215. So you're multiplying 3 with each of the elements of that vector. Right. So again, of course, these commands will take you a very long time if you manually solve them. So obviously you can type it into R directly, but don't just blindly type and get the answer and, take that answer. Take a moment to make sure that you've understood how R is working with this. Okay. Now, give me like 30 minutes to 1 hour. I will upload today's recording on the YouTube channel. I'll make a playlist for this this course, and both the PPT from today and the R script that we discussed today, I'll upload both of them on this Google Drive link. I'm just going to share you these two things in the chat right now. Both of them are going to be empty, so don't freak out. This is the chat. Everyone in the meeting. Okay, this I don't need. Yes, so you can get this. It is empty right now. The drive is empty right now. And in this YouTube, you would see other playlists from previous courses, not of this course because this is the first session. So give me like 30 minutes to 1 hour. I'll upload these two things here. You would get a separate email again, which would also have these links. So don't worry. For the first week, your assignment deadline is not in 2 days, but the week after. But after that, every week, the assignment deadline is going to be that week's Wednesday. Next session would not be like for week 2. I'll be conducting the session on Friday. Unfortunately, I have some work on Monday, so I will not be able to take the session on 3rd of Feb. Right, so it's instead of 3rd of Feb, it's going to be 31st of this month. So again, that session would also be recorded. Everything we discussed there would also be uploaded on the drive. So in case you're not able to make it on Friday, you would still have all the material available. So I think that's about it for this week. I'll stop sharing my screen. Let me know if any of you have any questions. Otherwise, that's it for today. Okay.
Thank you, ma'am.
All
Thank
right.
you
Thank
so
you so
much.
much, everybody. Thanks for joining in. I'll see you on Friday then. Bye-bye.